In this video, we are going to look at some different counting techniques. So in our first example, we have a pizza house that offers 2 different salads, 6 different kinds of pizza, and 4 different desserts. And the question wants to know how many different 3-course meals can be ordered. And so we use something called the multiplication principle, where we're going to take the number of outcomes at each stage multiplied by the outcomes of future stages. So I first have to choose my salad, and there are 2 choices, times. Then I have to choose my pizza. There are 6 different kinds of pizzas, times. Then I choose my dessert, and there are 4 different desserts. So if I multiply 2 times 6, I get 12. Times 4 would give me 48 different meals that could be ordered. In my second example, I have an auto manufacturer who produces 8 different models, and each is available in 5 different colors with 6 different upholstery fabrics and 9 different interior colors. And so they're asking me how many varieties of cars are available. So starting with the model, I had 8 different models to choose from, times 5 different colors, times 6 different upholstery fabrics, times 9 different interior colors. So now if I multiply that all together, 8 times 5 would give me 40. 6 times 9 is 54, so 40 times 54 would leave me with 2,160 different varieties of cars based on those selections. In my third example, we have a country's postal service using a 4-digit zip code. And it wants to know how many zip codes are possible if there are no restrictions on the digits used. So my digits are the numbers 0 through 9, which are 10 digits. If I have no restrictions, then that means that I have 10 choices for each slot. So the first slot, I have 10 numbers to choose from, times the second slot, I have 10 numbers to choose from, times the third slot, I have 10 numbers to choose from, times the last slot, I have 10 numbers to choose from. So overall, this would give me 10,000 different zip codes with no restrictions. Now the second part of the question wants to know how many would be possible if the first number cannot be a 9. So I still have 4 digits in my zip code, but if the first number can't be a 9, that only leaves 9 other digits. So I have 9 choices. Now, it didn't say any restrictions for the other numbers, so I'm back to 10 choices for the second slot, 10 for the third, and 10 for the fourth. So if I multiply that all together, then I am left with 9,000 possible different zip codes. In this next example, we get into something called a permutation. So a permutation refers to an ordered arrangement. So anything that puts things in order or gives them rank, such as, say, the office of president ranks higher than the office of vice president, etc., it's known as a permutation. So in this particular example, we have a student activity club at the college. There are 37 members. In how many different ways can the club select a president, vice president, a treasurer, and a secretary? So there are 37 members. They are choosing 4 offices, and we're using a permutation. So I'm going to show you how to not only punch this out on your calculator, but we'll also talk about what the formula means here because they're asking you to fill that in first. So N refers to the number you're choosing from. That's my 37. And you'll see with this formula, it has what we call a factorial on top. You're just filling in the 37. 37 factorial means you're going to take the number 37 and multiply it by every whole number less than that until you get to 1. So 37 times 36 times 35 times 34 and so on all the way till you get to 1. Now, in the bottom of this formula, you're going to take whatever your N is, so 37 again, and notice they're saying minus, you're going to subtract your R. R is the number chosen. So in the bottom, we would do a 37 minus 4, which would leave me with a 33 factorial. And then you could punch that out on your calculator with that formula, or most calculators already have a permutation key. And so I'm showing you the one from my Desmos Scientific Calculator, and you kind of have to know how your calculator expects you to input it. With Desmos, if you look under the functions menu, there's a function called NPR, which stands for permutation, and you're going to put your N, comma, your R, and then hit enter, and it calculates it for you. So it's doing that N factorial like over here, and it's dividing by the N minus R. So notice, in that case, there are 1,585,080 different ways to choose those officers. Now, the next question, we're talking about choosing a committee. And so when you're choosing things that do not have an ordered arrangement, in other words, there's no rank of one above another, you can think of it as a grouping, then that is known as a combination. And so with a combination, you're not going to have as many different outcomes because you're throwing away all of the repeated groups. So in this particular case, we have 10 students in a fraternity, and they're wanting us to select 5 students for a committee. So on my calculator, I would type it in as a combination. So in the same place that you found the NPR, you would see that there's also a key for the NCR. And again, this is just the one off of Desmos. Always put your N first, followed by your R value. And then once you hit enter, you'll notice in this case that I had 252 different ways that committee could be chosen. The second part of that question says, in how many ways can the group that will not take part be chosen? Well, how many people are not chosen? And in that case, there's still 5. So there were 10 to start out with, and there are 5 not chosen. So the second part of that answer is the same as the first because you're choosing 5 either way.